All right.
Good morning, good afternoon, good evening. Welcome to another episode of LMTV, particularly LMTV Sharkfest. I would like to quickly introduce my co-host, Tim O'Neill, and our special guest today, Paul Offord. But just to get, in case you're wondering, this is an even month. I don't shave on even month. That's why I look the way I do. Hi, Paul.
Hi, how you doing?
Oh, good. So you did spend some time on the left coast, as I understand, and had a great time at the Sharkfest. I was wondering, since Paul and Tim and I didn't go to Sharkfest this year, I was wondering if you could give us a perspective, especially from when you this is if I understand it, this is your second Sharkfest, but it's the first one as a presenter.
No, I presented last time actually.
Yeah. Oh, really? Oh, okay. But it's the first time you presented all 3 sessions.
I did 3 sessions. Yeah, that probably was a bit of a mistake. That was an overcommitment on my part. The shame of it was that it meant that when I first arrived, I still had some work to do on a couple of the presentations. And so I didn't sit in on as many sessions as I would have liked. The presentations went really well, as far as I was concerned.
One of our first former lady have an answer to that, which is just to say no. Just say no. Otherwise, you would be doing 5 sessions next year.
It wasn't Janice's idea. I was the one who volunteered. The crazy thing is that Jasper Bongertz, who presents regularly, I think he's presented at just about every Sharkfest there's been, he did 3 sessions and he was complaining because he wanted to do 5. And I thought,
okay.
I thought, my goodness, I struggled with 3.
Well, that's Jasper though.
You do 5.
Yeah, that's Jasper though. He's got to do everything. He's got to do. He wants one. He's one of the guys who wants to regurgitate the entire encyclopedia to you. He's so smart.
You know what though?
How is the venue? How is the museum? I mean, that was quite a.
It was great, really a great venue. I tell you what was really disturbing though. We had free access to the exhibit area, and I went down into the IBM area, and I saw several machines that I used to work on when I was a hardware engineer. That's really, some old card punches and decolators and stuff, and I was thinking, oh my goodness, I really have been in the industry way too long. So that was a bit of a. They had some great stuff though. They had a Google self-drive car there, and showed how it works and how it observed and understood the road environment. It was quite interesting, and they had some great exhibits. Really fantastic venue. I stayed in Sunnyvale. I didn't enjoy that much because there's not much there. Although they started to build a bit of a centre of Sunnyvale around a road. I think it's called Murphy Street. I can't remember, but.
As someone who was trained as a mechanical engineer, visiting the computer museum is a very sad affair because you could really see the decay of the profession.
True.
I mean, back in the 50s, we were somebody. We designed all the components, and then now we just we're the only thing we design is sheet metal.
Yeah. So I think in terms of as a venue for the event, I thought it was really good. As I said, I thought last time I went, we stayed in Berkeley, and I enjoyed staying in Berkeley more than I enjoyed staying in Sunnyvale. But as far as it was concerned, it was great, and as usual, Janice did a fantastic job. I mean, it just. Well, I don't know what was going on behind the scenes, but it seemed to run like clockwork from what I could see. So, yeah, very good.
That's awesome.
So I sat in on a few of the sessions. I sat in on one of Jasper's actually, and one of Chris Greer. His was good. I saw Betty there and talked to her, and Han Seng was there, and all the usual crowd really, and some new people besides. A few of us Brits, about 4 or 5 of us, I bumped into. But yeah, it's good stuff.
Excellent, excellent. So there was so you did 3 sessions.
Yeah.
And we posted 2 of them already.
Yeah.
And then, but now this is one that you already did at Sharkfest, but we decided to do it again, right?
Yeah. 2 reasons. One, it was actually quite well received, and I thought it would be of general interest. The other thing is all my recording, Camtasia and all the audio recording, all went wrong. So we have no record of it to post online. So I'm grateful for you guys for giving me the opportunity to present it again, because I think you know, it's useful information, and this is a great opportunity.
Well, I taught before I was an entrepreneur. I taught at university for 9 years, and my experience is always that the same lecture given the second time is always the best.
I hope so.
The first time you're not sure. The third time you're so bored, you know.
Yeah.
All right, so why don't we start? And this is part 1 of.
This is part 1. Yeah.
Okay.
The format of the presentations at Sharkfest, there was an hour and 15 minutes allocated, which was much more than when I previously presented. That's quite a long time.
Yeah.
The time still went quite quickly, as it always does with these things. I think we're going to get through it slightly quicker than that, but I've decided to split it into 2 anyway, so we'll go with that.
I don't know if you guys can see this statistics. I can see it at the bottom of my screen. We now have double-digit viewers.
Wow.
That's
and
good.
so even if I subtracted the 3 wives, that's still pretty good numbers.
Okay.
Hey, Paul. Paul,
Yeah.
you're always welcome to be with us. We just love the stuff you do, and it's great. So
Okay,
you're
thanks.
always welcome to be here.
Thank you. That's good. That's
So
good.
for those of you who are watching, just a reminder, we do have a Q&A panel. So go find that button that says Q&A and feel free to ask questions, and we might even answer some of them.
Questions in life are always guaranteed, but answers are not.
All right, Paul.
Okay, let's see if we can get this to run. Okay.
No aberrant behavior, Paul.
Are we okay? Can you see my slides?
Yes.
Okay, good stuff. So, as I said, thanks very much to Tim and Denny for allowing me to present this again. This was the 3rd of the sessions that I ran, and I'd welcome any interaction, any questions and answers during the session. That would be great. I will break occasionally for questions, so perhaps Denny and Tim can put them on behalf of our viewers. So I'm going to start off by looking at some basic concepts around analysis of network and application performance. We're going to look at something called the RTE model. This is request response time, a particular request response time model that's based around elements of the timings. Then we're going to look at this tool called Transum, which is a free Wireshark plugin, and I'll do a very quick demonstration in this first session just to show it working, and then we'll look at it in some more detail next time round. And I'm going to do some troubleshooting scenarios. They'll be in part 2 of our session. I'm going to use some particular terminology. When I refer to infrastructure, I mean hardware and network services and everything that's actually running our applications and our processes. Look at this tool called Transum, which is a free Wireshark plugin. Oh.
Denny.
Okay. Then we're going to, I talk about programs running in processes. I don't really talk that much about this, but I do want to get across the idea of processes that are running programs. So if we look at some practical examples of that, we can think of a browser talking to a web server talking to a file server, and the web server talking to a database. And if we look at that end-to-end system, we have different conversations going on, and different elements of this end-to-end system are representing either a client process or a service. And I call them service rather than server, because if you consider the situation with the web server here, we've got the web server serving up pages to the browser, but the web server is also acting as a client to the file server and the database. So we talk about clients and services. Now, if we think about TCP communication, to me, I mean, there's all sorts of ways of looking at TCP communication, but as far as I'm concerned, it's the way two processes talk to each other. We can touch on UDP later, but you know, TCP definitely provides this capability. TCP goes through these distinct phases of establishing a connection, transferring data, and then goes through some sort of disconnect sequence. So I'm particularly interested in the data transfer phase. So if we think about a browser, after it's established a connection to a web server, then we'll send, say, a GET request from the browser to the server, and the server will serve up a page. Now, when I look at this request-response pair, what I'm talking about here is what we call application protocol data units. So these are application-level messages, not packets. So there's a bit of a difference here between these APDU requests and mapping that onto packets, and we'll look at that difference in a second. Anyway, when the request arrives at the server, it munches the request around and then sends back the page, and the time it takes to process that request we're going to call service time. And the time experienced by the client we're going to call that APDU response time. So the APDU response time is basically the service time plus any contributory delays associated with the network. And here, as I said, we're talking about application messages, and we're not yet talking about packets. Now, if we look at a slightly more complicated scenario, you think about a user who clicks on a button on a browser. We'll see a request going from the browser to the web server. Maybe the web server needs to get some data from the database, and so it sends a request to the database. And the delay between receiving the request in the web server and sending a request onto the database server, I'm going to call that client time. And it's client time with respect to this client here, the client in the web server itself. So we're analysing it at that tier. The database processes the request, sends a response back. Maybe the web server has a think about it and processes that first response. It decides it needs more data from the database, so we send another request. We get more service time. We think about it a bit longer, and then we send the response back to the end user. So here, as I said, the client time here is referring to the time in the web server where the web server is acting as a client to the database. So let's just add on a bit more detail. The TCP connections all happen via ports, and the ports have numbers. So we have TCP port numbers. A very common port number for a web server is port number 80. And this particular database, which is a Postgres database, has a TCP port number of 5432. Doesn't matter too much about that particular which numbers are being used, but just to point out that there are these port numbers. So if we start to look at Wireshark Trace, for example, we can see this top packet is traveling from source port number 64006, and it's going to a destination port 80. So this is going from the client to the service. And then later on, further down in the trace, we see a packet in the opposite direction. We see packets in the opposite direction going from port 80 back to the client port. So that's the request in the first packet, and then we see a sequence of packets representing the response. So here we start to see the difference between a request and a response application message and how that maps onto packets. So let's just look at that in a bit more detail. The request here is a single packet. They don't have to be single packets. If this was a post request to a web server, for example, it could be posting more than the amount of data that can be contained in a single packet, and so it would be split across multiple packets. But in this case, it's contained within a single packet. The response, however, has to be split across 4 packets because we've got, say, 5,000 bytes of data or something. So there's that difference between application messages and packets on the wire, if you like. So this is where we start to introduce this idea of response time elements. So there are different components to the response time that we're seeing here. We're seeing the client time, then we see, say, for example, a database request that has to be split across 4 packets. So we have a database message, but it's actually contained in 4 packets. Now that may take some time to transfer that across the network. Now the time it takes is affected by things like network latency, load, queuing, retries, and TCP window sizes and TCP window management, congestion, all of those things, the sorts of things that you'll see Chris Greer and Hansang and Betty and people like that talking about. That's exactly the area that they're focused in on, and that's where you'll get that type of guidance, looking at how long that takes. Now we're going to actually give that time a name, and we call that the request spread. So that's the time it takes to actually send a complete request to the database. Then we have service time, which we've talked about already, and then the response may similarly be split across multiple packets, and so here we talk about response spread. And again, same element, the same factors affect this, things like congestion and queuing and all those things. The total time taken here, we've already said, is the APDU response time. So an important thing that you note here is that APDU response time is first request packet to last response packet. First request, last response. The service time is the last request to the first response. So there's the distinction between packets and APDUs. We've got some more client time here, and then maybe we send the response back to the user's browser in 2 packets, and of course there's some more response spread there. Now one thing I've noted down here on the right, all I'm showing you here is packets with TCP payload. Interleaved with these packets we may have standalone acknowledgements and other things. But what we're looking at is packets with actually carrying a payload. So let's consider this example. We've got a PC that's opening a PDF, and so it's reading packets, and then we're going to look at some trace entries associated with writing a Word document. I have a feeling actually that opening the PDF. Yeah, no, that's correct. So we've got opening a PDF and then saving a Word document. And what I've done is I've run a trace actually on the PC. So let's have a look at the typical trace entries. So here's where the PC is reading from the server. You can see a read request is the first packet, and then you see the response, but the response is split across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 packets. So in this case, we've got a single packet for the request and 10 packets for the response. So here's the response spread. Now, we get the actual information, the annotated information here in this last packet, because we have a particular option set on in Wireshark, and that option is called sub-dissector reassembly, and that's the default setting out of the box. So if you install Wireshark on your PC, that setting will be enabled by default. Okay, so in the detail of this packet, if I go into the detail of this packet here, number 267, what I find is down here I've got this value, time from request, sorry. So it's the time from receiving this request to actually down to this last packet. And you can see a value in there, it's 463 microseconds, and that value includes what we've talked about earlier as response spread. So that's good, that all looks good, no problems there. If we go on to look at a write scenario, this is slightly different in that the write command is split across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 packets, and then we get a single packet response going in the other direction. So in this case, there's the request spread. We don't really have any spread for the response because it's a single packet. We've got the same setting in the sub-dissector settings. Reassembly is enabled. This time we've got time from request as being 10.5 milliseconds. But this time the request spread is not included. So the 10.5 milliseconds simply refers to the time difference between this last packet here and this packet here, the last request to the first response, which is really more like a service time rather than the APDU response time. And this is really where we started to, this is one of the reasons we wanted a Transum type tool, is because there are inconsistencies in the way that response times are handled in Wireshark by default. So they're best summarized here. If you've got reassembly enabled, you don't get request spread, but you do get response spread. And if you've got reassembly disabled, you do get request spread, but you don't get response spread. So you can never quite get what you want. So if we want to look at accurate APDU response times for a read command, we'd have to enable reassembly, but unfortunately that means that write commands won't work. And then we have the opposite effect with service time. So whichever way we look at it, we can't get a consistent set of results. So these are the sorts of reasons why the drivers behind taking a more structured approach to response time analysis. So before I go on any further, do we have any questions so far?
Jenny, do you see any questions?
No. How about yourself?
Okay.
No.
Mm-hmm.
All right. No problem. No problem. We can go on. So another thing that's important for the our approach to troubleshooting problems, and I would say that this is something that everybody needs to consider, is that there's one way of looking at performance problems on a network, and that's to start from the bottom and work your way up. So maybe if I'm taking it in a literal sense, maybe I start by testing the cabling and the fiber, and that's all good. So then I go to the data link layer and I start looking for frame check sequence errors, and that's all good. And so then I move up to the network layer and start looking at trace route commands and pings and checking for time to live, for routing abnormalities and things. And so I can take that approach. For us delivering a commercial troubleshooting service, that wouldn't play. We have to do it faster than that, and we have to have a better way of linking what we're doing into what the user perceives as the problem. So we take a top-down type of approach. So we start off by looking at the user's perspective, And the closest thing on the wire to the user's perspective is the APDU response time. So now you start to understand why that particular value is so interesting to us. We can then drill down and find things like service issues and even network issues, but we tend to start from the top and work our way down. So we find that faster and more reliable. So to do that, what we need is we need something that can give us accurate APDU response times, and that's measuring first request packet to last response. And we also need something that can give us accurate service performance, and that's last request packet to first response packet. And so this all feeds into our response time element model, which was actually developed by a colleague of mine back in the mid-90s, actually. Neil Hatton started to do some work on this and started to explore how we could process data to actually find out some of these types of values. And he wrote a suite of programs based on a language called SAS, which was a language that can process very large amounts of data quickly, and importantly it can process many types of data, binary and text and all sorts. So we started off with that, but we've recently ported Transum to Java, so it's now forming part of what's called the Advanced 7 Java Toolkit, which is a tool that we used internally for delivering our services. And then we mapped the Transum capability into a Wireshark plugin. Now I have to say that none of us had ever written a Wireshark plugin, and we wrote it in this scripting language called Lua, which is a language that's supported by Wireshark. So it was a pretty steep learning curve, and I wrote a lot of the code, and I'm not a programmer, so my code is a bit messy, but it does the job. So we've been developing it, and the release that's out there in the world at the moment is release 9. We're beta testing release 10, which I'll talk about later. We've already started some work on release 11. So let's talk about how you install Transum, because it couldn't be simpler, quite honestly. It goes into one of the Wireshark directories. Now we install it directly into this directory called plugins. You can actually install it into a subdirectory underneath plugins in this subdirectory called 1.12.6 or whatever your Wireshark release is. The difference is that if you install it in the 1.12.6 directory, the Transum plugin will be installed every single time you start Wireshark. We prefer to run Transum when we want to run it, and so we start Transum with and Wireshark with a particular batch file, and I'll show you how to do that in a second. So, taking my life into my hands, I'm going to demo installing Transum. So you need to go to install it. You need to go to this site called TribeLab0.com, and once you get into that site, and you don't have to sign up for this, you can just go straight there and you can download Transum directly from here. You go to this resources page. Tim, can you just confirm you're seeing all this? You see my browser?
Yes, sir, I am.
Yep. Okay, good. Thank you. And on the resources page, if we go down, we find Transum Wireshark plugin. We click on that, and this diagram you'll probably recognize from the presentation. And over here, we actually have the code for the plugin. So if I click on that, and I save it directly into into the plugins directory. And let me just open up that folder. So now you can see I'm running a a later build of Wireshark. I won't tell you why, but it's just because I was having a particular issue, which is solved in this particular release. But this will work in any release from about 1.12.0 onwards, I would imagine. I think I've tested it from 3 onwards. Okay, so we've got this loaded in here in program files, Wireshark plugins. It will work on OS X on a Mac, and it will work on Linux. It just goes into the equivalent plugins directory. And then I've got this particular batch file to run it. So it just says Wireshark -X, and then it's got a reference that points to the Transum plugin. So let's actually try running that.
While you're doing that, Paul, are there any restrictions? Do any of the antiviruses or malware tools, Microsoft Security, anything come up and ask you or inquire about downloading the file?
I haven't had any. No, I run Symantec AV,
yeah,
and also there are quite a few. I think there have been about 250 downloads of Transum, unique downloads, and I haven't had anybody tell me that they've had any problems. So I don't think there are.
Yeah, I was just mine.
No, it's good question.
About running it and seeing, and I gotta. It's probably just because of the security I have in this computer.
Okay.
It came up.
All right.
And I loaded it on. I'm loading it on another computer while I'm trying to do it right now, and it looks like it's fine. So it must be just the security on this one computer.
Okay, all right. We should talk about that offline. I'll be interested to know what the issue is. So, okay, so I'm going to just go straight in and load up a file. I've got a file here that's got some web traffic in it. Let's pick that out. So we can see typical stuff: syn, synac, ACK, and then a GET request for the root of a website. And you can see that over here, even with the syn packets, I'm now getting Transum data. So you can see that what it's saying is it's used the syn-synac subdissector within Transum, and it's saying that I've seen a request, the first segment of which is packet 11, and because it's only one packet, the first and last segments are the same. It's seen the response in packet 16, and so it's then gone ahead and worked out the timings, the timing measurements. Because it's a single packet for the request and response, there's no spread, and that means that the APDU response time and the service time are the same. There are some limitations around this, which I'll point you to in a minute, just to clarify that business about the two timings being identical.
And Paul?
So, yeah.
I was just going to mention that your website, the TribeLab0.com, has a lot of this, if people want to go and look at it, and other resources on your courses and things like that.
Sure, yeah. There's an awful lot on there. Even the user manual for Transum has got a lot of the information that I've talked about here on the presentation. So what you can do, of course, is once we have values here, I can right-click and I can click there and apply this as a column. Now, rather than do this in my default profile, I've actually created a profile for Transum. So what I can do is switch into my Transum profile to reapply my filter. And now we're seeing the timings here in the summary line. And I can see that I've got timings for the SYN exchange. I've got timings for this GET request. I've got another session starting here. I have timings for that. You can see that for the page here, for this GET request, I've got a single packet for the GET request, but I've obviously got multiple packets for the response because it starts at segment 67 and it ends at, packet 67 and it ends at packet 73. So 73, sure enough, has the 200 OK in it. Now, Transum comes with some options. One of them, and we can go straight in here, is we can actually generate a trace clip filter. So that generates this additional piece of information here, and I can right click on that. I can say copy the value, and then I can paste that into my filter. And so now what it shows me is just a trace clip showing just that transaction. So that's a really quick way of getting in there and looking at that type of information. Also, what's useful is because, of course, now we've got these APDU values in a column, I can order it by column. So I can look at the slowest web service calls. So I've got one there that takes 1.12 seconds, and it's a get for some jQuery JavaScript stuff. So you can see that it's very quick to get in there and start looking at problems. What's also useful is that if I clear down that filter and I just type in the word Transum, now what I get is all of the Transum calculations. You can see that I've actually got some SSL stuff in here as well, and I've even got calculations, timings for the SSL traffic. So the whole idea here is just to make it much quicker to troubleshoot problems, to be able to get in there, display these timings, and then start troubleshooting straight away. I'm just going to show you a couple more quick things, and then I think we should stop at that point. So I've shown you SSL anyway, but here's some database stuff. So here we've got database requests, and we can see the timings on the database requests, so we can see how fast the database is responding to SQL queries, and that's also very useful. It's great to be a network person to be able to go and show a DBA, a problem with an actual SQL call. So that's particularly useful. So I can pick out the SQL call down here. You can see it's a select statement, select top 200, rec ID. I've got the full SQL statement down here in the packet. And as we know, packets never lie. So this is really good evidence for actually showing a database administrator some performance problems in the database.
Well, it's also important for people to benchmark their system, because if you don't know what is normal when something's aberrant happening, you won't know it. Because
sure. Yeah, you can use it for that too.
Yeah, baselining is an imperative day.
Yeah, I mean, one of the benefits is that once you've got it down to this type of level, of course, one of the things I can do here is I can just do export to CSV. And so I can export out all of those packets that are being displayed right now that include all the Transum data. I can export it into Excel, and then I can produce a graph that shows performance over a period of time. And some of the things we've got coming up certainly in release 11, we're going to actually provide more summarized information about post requests and SQL database calls, so that you can extract all of that information in a single line and export it out to Excel. And then you can do all sorts of clever things like pivot tables and all sorts with it. So the only other thing I wanted to demonstrate here was, if we go back to the website, as Tim has already mentioned, we have this user manual. The user manual has all the information about why do we need Transum, the response time element concepts. You recognize some of these diagrams. Some of the limitations with the way that Transum calculates response times, but it's got ways to overcome that. Transum Release 9 has SMB2 support, which is particularly important because it overcomes some of the complexities of dealing with the Microsoft File Server protocol. Some pieces here about the accuracy of Transum. It doesn't support T-Shark right now, but actually the next release will. Release 10 will support T-Shark, so we fixed that particular problem. And that's it.
That's a lot, trust me.
That's a lot. So let me stop my screen sharing. So, a fast and furious tour around Transum.
Yeah, I think people ought to try this and start trying to figure out benchmarking over their technology, because right now with all the local people, most of the statistics are indicating that web applications are getting hosed pretty quickly out there because there are so many of them been breached or have vulnerabilities. And if you don't benchmark your web apps or even your database apps, you're not going to know what happens and how well it's happening. And if there's any aberrant behavior, you're not going to know it.
Yeah. Yeah.
So this is a great get to know your applications tool to add to
Yeah, certainly from a performance point of view, that's definitely true. I mean, it's the Transum version that we started with, the SaaS version, we've used it so much. I mean, it's a really heavily used piece of software, and now we've ported it onto Java. It's becoming very heavily used as well, as far as we're concerned, in terms of analysing performance. So, yeah, we found it invaluable. And the feedback we've had from the Transum plugin that you've just seen has been very positive. There's some people who troubleshoot problems for a living.
Betty, Mike, Tim, Tony.
Yeah. So they've all discovered that that it can be quite useful in troubleshooting that.
Okay. So Paul, what do you have planned for the second part, which we will do next Wednesday?
Sure. So what we're going to do is I'm going to demonstrate troubleshooting a couple of problems using Transum. We're going to have a look at the next release, because the next release, which should be out within a month, I would think, because we've just got some people beta testing it at the moment. That includes DNS support, which people have been asking for. It's got support for generic UDP analysis, so analysing any UDP system as long as it follows a certain set of rules, which are described in the manual. IPv6 support, which I had some help from a friend, Vladimir, actually gave me the code to put in to help it successfully support IPv6. So we've added that code into it. So that's been good. And the T-Shark support, which I'll demonstrate. You may think you may think, well, T-Shark, that's nothing special, but actually, with using T-Shark and a very simple DOS batch file, you can process terabytes of data, and I'll show you how to do it. It's really easy to do, and that means that you can take 500 trace files and summarize them using the Transum Lua and a simple batch file.
Wow.
Yeah.
This could be something you're going to give out to people. That's going to be.
Yeah, the batch file details will be in the user manual, actually, and I'll show you the batch file content in next week's session.
And one thing, Paul, do you SHA or hash your download?
We don't actually.
Okay.
That's a good point.
Yeah, I think today, and I would use a SHA. I wouldn't use hash, because standard hash, because almost all of them have already been hacked, but it's good as a baseline for when you're downloading files. And I found out why my computer won't let it work. It's got Java open. It's got open jars, and my system says you can't run Java on me, and so it's locked down pretty tight. So
yeah.
So
well, that's nothing to do. There's no Java involved in this Lua. I can tell you that.
The new one or this one here?
No, there's no Java involved in this. The Java toolkit, this isn't part of the Java toolkit. This is an extraction. So I reckon you've got another sort of issue, I guess.
Yeah, I have to go back and research it.
No, this is just a script file. It's about 1,500 lines of script.
Okay, I'll check it again, but it came up and said that there was active script in it and it wouldn't run.
Well, it could be because it recognizes Lua as a script. That's possible.
Possible. Okay, yeah.
Yeah. That is possible.
Yeah.
Okay.
Runs fine on this computer, but not that one.
Okay.
Okay, so with that, why don't we just take a pause and meet back next week?
Sounds great.
All right. Okay.
Great job, Paul. Great job.
Good job, Paul. Thank you.
Okay, you're welcome. Thank you.
Okay, and see you soon. Bye-bye.
Bye.